So our next speaker is CTO of EPAM Ukraine, Yevgen Mospan. Yevgen, welcome to Javon.
Hello, everyone. Hello, Roma. Thanks for invitation, and I hope that everybody is ready for the second talk.
Yeah, I do hope too. So, guys, maybe you don't know. I think Yevgen is first time you are on the stage of Javon, right?
As a speaker, yes.
Yeah. So you don't know. Yevgen is our like angel keeper. So he is always behind the Java on conference. He helping us to organize that all these years, and I really appreciate. I want to say thank you again for all the job you made for us. So he was backstage, like always, just helping us, like Godfather, something like this. So
Uh,
thank you very much from all the team,
Roma, it
from
was
all
a
the audience.
pleasure. Really, it was a pleasure because conference is always people. It's always speaker. Who is a backstage, they are only supporting, so they do not really do a lot. Believe me.
Okay. Anyway, thank you for all organization team. Thank you for all the audience. So, guys, yeah, we have a couple minutes before the official time to start. I just want to say some general information. So, all the conference is being recorded. No worries. All the streams will be available right after the end of the stream. After the end of the conference, we will cut talks separate and we'll publish them on our YouTube channel. So subscribe to our YouTube channel not to miss all these talks, and of course you can rewatch any talk anytime you want. And yeah, I will collect your questions in all the chats we have. So we have YouTube chat, we have chat on their community platform. So I'm looking in all of them, trying to collect the questions and see what I can ask to our speakers. So please don't miss this chance and ask your questions. So right before we jump into the talk, and Evgen, I can ask you meanwhile to share your screen, so we'll have it prepared. Um, yeah, so maybe like a general question. Maybe you can give us some hint. What would be your talk about? So it would be about AI, but what exactly?
It will be about new methods, how you can work with AI, but let me try. Uh, so it's a window, it should be like this. Um,
Yep, I think we
No,
can
it's
see, but
wrong.
no, it's the wrong
It's
one. Yeah,
wrong.
yeah, it's
It's
the wrong
wrong
one.
one. Yeah, let me try it one more time. Uh, just a sec. Um, here we go. I believe this one should be correct. Yeah, this one should be correct. And
Yeah. So
and
I hope people will not hate us at the start. Just a couple minutes earlier. Again, all the records will be there, so you can always rewatch it. And yeah, small reminder: we collect your questions in all the chats. So Evgen, Java is on. Good luck. Stage is yours.
yeah, thank you, colleagues, for joining. And today we are going to talk about new methods of working with AI. And let me tell you about a couple of words about myself. So I'm working at EPAM for about 10 years at the moment. And right now I'm a CTO of EPAM Ukraine and work also as a senior director with a focus on a solution architecture. My main streams are technology consulting, architecture, and research and development activities. So AI actually belongs to this one. And I worked in a really big project, in a like really interesting ones. Among of them, I would like to distinguish two. So it's My DHL Plus and DIA. So who of you are from Ukraine, you know about this project. For the rest of the world, it's like a national mobile application in Ukraine from government to simplify life of people. And basically, this was one of um, the most challenging project I ever participated in. But at the moment, my focus strongly belongs to AI and how you can apply it in, from one hand side, SDLC processes, but in the same time in all what I call here human-machine processes. So, and that is why, and by the way, Roma, can you please just tell me that everything is okay? Slides are being changing, so you hear me well? Okay, so that's great. And actually, I want to discuss with you is really GenAI a game changer right now. And we are going to talk about AI agents and what we call AI workflows. So workflow AI agents is basically right now known term. Everybody is calling it in this way. With the AI workflows, there can be some deviations, some differences, but you will, I guess, you will understand what I am talking about, and probably you are trying it already. And I also want to show you current level of adoption here at EPAM, what we do, and what we believe will be our next actually way of working with software development and probably with some business application development and changing the business processes on our client side and their customers. So let's start with like generic human machine processes and what is hiding behind. This picture is of course generated by AI, and I just wanted to illustrate that sometimes in a human machine processes, humans start to behave like robots. And you can probably recognize some parts of your job as this process. When you need to fill something, to transform something, to pass some information to another person just to make things done. And usually it is like some routine operations with minimal creativity. So you don't like to do it. And actually, in this way, it is non-human interface. So you just cannot talk. You just cannot think about it abstract. You need to make it really concrete and feel some interfaces and so on and so forth. And you work in a highly standardized processes. So one important piece is basically that that transformation that I mentioned. And actually, you are not really creating something. You are just transforming the previous version of the artifact to the newer version. And mostly it is related to text. And in some cases, and not only text, of course, but in the way that machine can validate your actions and basically to tell whether it's right or wrong. And the typical challenge with this kind of processes, they are really boring. And effective workers in these processes, they must enjoy this routine. So it's like going to gym and liking all the physical exercises. So when I go to gym, I like to do different stuff. So I cannot do the same stuff every day. So it's really boring for me. This is the kind of person I am. You can be different, and it's okay. But really, when you have the repetitive process, then you need to enjoy it to be effective. And the high risk of burnout, it appears in such process. And because of two previous points, you as a manager, so here we talk about different roles in the process, you need to control and to coordinate. And actually, the weakest point of these processes is talent suppression, because the people inside the processes, they cannot extract all their creativity and bring it to the table. So it's hard to do for them. And let's try to take a look on a process that we all understand. So it's like a classical SDLC process. You can call it agile, you can call it to some extent waterfall, but really, so it depends on the level of abstraction you're looking into. Because if you look on the process from the system perspective, and you have iterations, and you can change your backlog anytime, you can prioritize, you think you're agile. If you go to the level of the feature and you have started, then you have a waterfall, because you go through really strict stages that defined in your process. Sometimes you can skip something, of course you can be flexible, but still you cannot avoid requirements analysis. You cannot avoid coding, then deployment, then testing, and so on and so forth. And actually, usually one feature takes like 14 calendar days to to develop it with the help of cross-functional team. And actually, we have a bunch of different roles, at least here at EPAM and probably in your organizations. So we have product owners, BAs, solution architects, dev and DevOps, and so on and so forth, who are working on this. And lots of them got last year a great help from AI tools, from copilots, and they started using them. And in this process, so the major challenges are actually extended feature development timelines, because I started my career 20 years ago, and we didn't have that many amount of roles. So usually you were the only person who was delivering code from the requirements to production. And you were alone, so you didn't have to pass information to other persons. The complexity was not that high, and that is why it was possible. And actually, right now, that turned a little bit from other side of the coin, because we have a lot of people in the place, and that is why we have to pass information. We need to make it clear, and that is why the timeline grows, because we need to keep the availability of the persons and so on and so forth. And in this environment, actually, the cost of experimentation and modification can be really high, because you don't know how the experiment will go, and so on and so forth. In the same time, it's growing the complexity of edge case testing, and you probably have seen this, that you have too many ideas in the backlogs which are contradicting each other, and nobody knows exactly what it is about, because the idea looked to be really great at the very beginning, but in 2 weeks it's like not really that great. Nobody wants to work on it, and that is why nobody understands why it was created in the backlog. From team challenges, actually, we got too many roles, and that is why we get and too many people inside this process, and that is why we got actually lots of communication. In the same time, it's really hard to automate all the transfers between the different stages of the process. And when I say limited automation, I'm not saying that DevOps are not doing their job. So they do. But actually, when you want to really automate collection of all metrics, you need to dedicate a lot of resources to it. If you want to analyze something, you need to dedicate a lot of resources to it, and so on and so forth. And because we as humans are not perfect, the technical and security depth is growing. So it's like normal situation for any product. If you pay attention to it, you can manage it, but it's a natural way of developing the software, that the security and technology and technical depth will grow. And let's talk. So we talked about like what we have, and right now I want to focus on GenAI and try to answer the question that I raised before: is it a really game changer, and how it can help? So here at EPAM, we see 5 different ways how GenAI can actually affect such human-machine processes. And actually, it started long before like appearance of GenAI, because we all have our favorite IDEs with some IntelliSense, and we are not doing everything manually. So there was a lot of automation put already in place. Right now, when we have copilots, so they can help much more than usual patterns and some quick keys that we use in IDE. So they can work with our context, with our tasks, and help to propose different solutions. So the most famous answer that I get from the developers on the wave number 1, I stop using Stack Overflow. So because I can use GenAI to get the answers by just talking to it, talking to my repository, and actually it uses some context from the code that I already have, and that is why it simplifies the search of the solutions of the potential problems that I face during the development. And of course, it's true for Java engineers and for all other engineers in place who are working with the code. So this is language agnostic. The second wave is a little bit more complex because it introduces AI agents into the place. We will talk about them in more details, how they look, but the main difference is that you delegate to AI not just to give you advices, but to do some stuff. So how it works, I will tell you a little bit later. And with wave number 3 is basically starts when agents starting driving the process. So they involve human when they are needed. It's the most crucial change between wave number 2 and wave number 3, because in wave number 2, you still remain as a human in a pilot place. You tell what to do. Of course, you can have some limited automation around this by actually triggering some agents based on events and so on and so forth, but still you are still the main hero. On the wave number 3, the idea is that AI agents involve human when they stuck. Like in a classical industry automation right now, where we have factories without human at all on the production lines. So it can happen with different human-machine processes outside the classical industry. The wave number 4 and the wave number 5, I prefer not to talk about them at the moment because it's really far away from this year at least. But still, it's something like Raymond Kurzweil is telling us. So it will be near the technological singularities that can happen. But as a practical person, I would like to focus on a wave number 3 and the wave number 2 and 1. So let's see how it can affect the teams and what can be the gain when we start using new methods of working with AI. And when we say here productivity gain, I would like to explicitly mention that it doesn't mean that it is about working faster or harder. So for me, all the productivity gain we should get from AI is vice versa. So for me, it's working easier. It's making the stuff in a more sophisticated way, without interaction with other person, when you can rely and delegate some work to AI and not to do a lot of stuff manually. So this is actually the main point that I would like to make, because in some cases, people think that introduction of AI will either steal their job or will make it more complex. In my eyes, it only if it makes it easier and only if it gives me some time back, then it is effective, and then there is a productivity gain. Because when I am given my time back, I can do creativity, and that is why I can create really something new. So AI should focus on the stuff that I do every day, and I don't want to do anymore. If I like doing this, it's okay. So it's my routine. I like it, and there is nothing bad that I am not using AI. But when I'm actually already tired of it, I want to delegate it. And if I delegate it to human, most likely I am like creating this cycle of continuous delegation of the boring job that will still continue. If I can delegate it to machine, then I can like break this cycle. So this is the main idea. And with the wave number one, the productivity gain is not that big because it mostly focuses on individual productivity. And if you are doing your work faster, this doesn't mean that you really influence the calendar time for the feature. And this doesn't mean that your customer will get it faster. So this is actually the main, I would say, constraint of the wave number one, and the main driver why we should not stop on it, because it doesn't really solve the main problem that I was trying to describe. With wave number two, it grows a little bit because you can actually, with the help of agent, and again, so I need to postpone conversation about the agent a little bit for a later time. You can get expertise in the area where you're really not certain. So I'm coming from the Java world as well. So I was a Java engineer. To do the job that I was describing, I had to learn SQL, I had to learn JavaScript, I have to learn some DevOps automation, and so on and so forth. But really, I'm not that experienced in those kind of languages because my main focus always remained Java. And actually, what I've noticed that, and actually all experienced engineers knows this, are noticing this. So this doesn't. This is not about the language. This is about the engineering process itself. And when you know what to do, you just need to learn another syntaxes. And sometimes it takes a lot of time. With the help of AI, you can have only one syntax, and this is our native language. So what I call technical engineering English. If I can do engineering work with the help of English, then I get in the universal tool, because in this way I do not need to be that experienced in some specific languages. I just need to explain what I need to do and to validate the output. Of course, it is not about like this will be world-class code. So it's not about that at all. And of course, I need to understand what I see. So the biggest issue with AI that we all noticed in our research group, that it works only for really experienced persons. So it will not work really well for juniors. And that is why, because you notice that. So AI continuously generates bullshit, and you need to understand whether it's bullshit or not. And in order to make a judgment, you need to be an experienced person, and it's okay. So the main difference is that you can delegate some stuff to agents, like creation of the unit tests, if you are not following TDD process. Because TDD is great, but my own experience shows that I was more effective not using TDD, because I can do a lot of stuff in my head. But in order to make it maintainable, I still have to write unit tests. And if I can avoid this by delegating it to AI and just checking what was created, then it can make my work faster. And with wave number 3, actually, we expect that some of the processes can be created almost automatically. But I want to go back a little bit to the wave number 2 and talk about AI agents, so what they do, because I promised to tell, and actually was postponing this explanation a little bit until I get to this slide. So the main idea of the agent is that it's just not giving you advice, but it can do some action. And that is why it consists of like 4 major components. It's prompt, which is describing the behavior of the agent. It's planner, so it's agent brain, which decides what needs to be done. It's actually an executor. An executor is basically a component that can call the interaction with the system of record. And actually it is shown here, so you can do actions in Jira, you can do actions in Git, you can do actions in Confluence, and whatever that has some interface, either command line interface or REST API interface or any other interface. Because how it works, the LLM just generates the request that needs to be called against the system of record to get the data. So let's say if I want to create an agent which works with Jira, and I will tell it what is assigned to me, LLM knows that Jira has an API to search for the issues. It knows that there is a GQL, and it can create a GQL query that will say, okay, assignee equals current user. And it will give this request to some piece of code, let's say written in Python or any other language, which will call the HTTP request, get the response. So in the response, we will have textual information, and LLM will be able to transform it to something readable and more applicable to the agent context defined in the prompt. And of course, there is a memory which allows agent to remember what was happening before. So the major challenges that appears with such kind of architecture and usage of AI, that you will always have a challenge to understand what you want to create, a universal agent or dedicated agent. To be really honest, to create a universal agent, it's very hard. So at least for our team, so we didn't manage to do that. We stopped on the dedicated ones, but then you get a lot of agents that you need to orchestrate as a human. And sometimes it is fun, because when it is new, you say, okay, so the machine can do the coding for me. It's cool. Okay, I will do that. But when you notice that it continuously making mistakes, you are getting tired, and you say, okay, I will do it myself. So this is actually instability, and there is always a regression, because when the new LLM appears, you need to adapt your prompts again. You need to adapt your actually project context stored, let's say, in like retrieval augmented generation style. So when you create embeddings or use graphs and so on and so forth. So basically, there is a very big risk that what worked yesterday will not work today. And this is unstable. But in the same time, you can create agents that can be really useful, that can do like code reviews, that can generate some tests, and so on and so forth. And we created like lots of examples in our internal EPAM tool that we call CodeMe. We have like lots of templates which are actually helping people to do the job. So you can see here like QA checklist assistant. So it helps to generate checklist in a necessary format based on the QA input, of course. So there is a design to code assistant when you give some picture and it creates the code, like boilerplate code for it. So it's to some extent, it is always working. But let's go to a little bit more complicated story, to way number 3. And actually, there are 2 concepts of AI workflows. This is a sequential and autonomous model of the AI workflow. The idea is, so when you have a sequential way, then you have a set of agents. As I said before, remember, so we have this challenge. So it's either universal or dedicated. So if you have created a set of agents, let's say One of it can fix the sonar issue. Another can generate the unit test. Then another one can do the code review. And you need to combine them all together in a CI pipeline. Then you know in what order. Then you can use the sequential workflow. And you can say, okay, so I have a set of atomic agents based on which I can create more complex flows. And I can actually have a better reflection on the actions that agents performed on the certain stage in order to guarantee better result in the end. And actually, we have created several examples of such workflows, like unit test coverage. So based on which you can actually take the repository, run, if it is Java, so let's take Java repository. Then I can run Jekako report, define what classes are not covered enough, and say to another agent, okay, so you have a task to cover this class. And it will generate some unit tests. Then I can have the agent which will check either they work or not, either they compile or not, return this feedback back to LLM in a fully automated way without even touching it, and get the result. The average results that we were getting with unit tests based on the unit test, based on our test repositories with this agent is about 70% from zero. So which can be done like really fast without human interaction, and it is cheap. So from the cost perspective, it's much cheaper than the developer time. Of course, if we compare the best engineer who will create in the unit test and the unit test generated by AI, you know who will win. So it will be a human at the moment. But at some moment, humans were winning the chess against computers. But now it's not the case. And from competing with a machine is a game that you will lose anyway. So there is no need to compete with the machine. You need to benefit from the machine. And if you can delegate certain set of unit tests to be generated automatically, just do it. Do not compete with the machine, because if you will prove it, then you are better than the machine, what you have proved. So it's already given, because humans are better. But if they are better, they need to do the stuff that the machine cannot do. So that is the most important message that I would like you to give, because it's not about getting your job away from you. It's giving you time to do the creativity. With the autonomous workflow, the situation is a little bit different. You are not specifying what needs to be done exactly. It's more about like a way. Then you have an orchestrator, so the supervisor here, which defines which agent will work. So let's say that you have created, so you want to do some really simple tasks fully automated. You say, and you want to put them into classical SDLC process, like create a Jira ticket, then actually do the coding, then do the testing, and so on and so forth. And actually, you can have actually a set of agents that will do simple tasks. And the supervisor will decide whom to call afterwards. Because if I say just paint my button from red to green, then it's pretty obvious even for AI that first of all, you need to create a story. Then you need to create a code. You need to create a merge request. You need to commit it. You need to write some tests, and to deploy it to environment. And actually, all of that is possible with AI workflows to some extent at the moment, of course. And the better you understand your problem, the better you can actually split it into really understandable for you pieces that you can explain, that you can actually describe in a native language, in this English engineering language, the better you can give the tasks to AI, and the more effective it will be. This is actually the real example what we do. AI workflows we call externally as EPAM AI run trademark, and we actually hide these new methods of working behind this term. And this slide illustrates our participation in a SWE benchmark. So SWE benchmark is devoted to understand how AI can be effective in solving GitHub issues. So in real coding. At the moment, they have a verified data set which was collected by real Python developers hired by OpenAI that have created a data set of 500 real GitHub issues in real GitHub repositories like Django, like Astropy, like famous Python repositories. And the idea is that AI can use any technology. So, the team can use any technology, any approach using the AI, with the help of which they should try to generate the Git diff which solves the problem and pass it to evaluator written by the SWE bench team in one shot, so in one cycle. And if evaluator thinks that it is solved because it has a bunch of tests written, this issue was solved by human, it can be compared, so it can be said that AI solved it. So at the moment, we inside the EPAM have achieved the result of 39.6% using Claude 3.5 Sonnet as an LLM. So before October, GPT was like state of the art. In October, Anthropic introduced Claude 3.5 Sonnet, and it was like a game changer, at least for this test. To be really honest, I think that there is a very big influence on the data set that was used to train the model, because the impact of usage of the Claude 3.5 was really significant. On GPT, we got 27%, and then we get like plus 12 just by changing the model. So we didn't change a lot on our side, but the model itself like increased our results dramatically. And that happened if you take a look on the leaders for most of the teams. And you see the leader right now is 53%. So what I want to convey with this message, imagine that you have 250 out of 500 defects on your real projects solved automatically in your technical depth, in your regression depth. So you, as a teams, will never even get to that because you will have no time. AI has time. You just need to pay. And that is why there is a potential here. Of course, it will be not that easy. Of course, you will face lots of problems, but still, you can automate a lot of stuff that continuously appearing in your product or in your project, in your code. and you can solve it with AI. And this is actually the new ways of working that I was talking about. And on the next slide, I would like to show you a video with a real workflow that we have created like almost 2 months ago, when we wanted to show the possibilities of using AI in the area of migrating the Java applications to AWS serverless architecture. And actually, the pipeline can be really difficult, so it can involve a lot of tools that will actually recommend you what to do in this piece of code or that piece of code in order to be compatible with cloud environment. And you can introduce a lot of agents who will do the job. But let's better take a look on this video, and I will comment what is really happening. So we see that we have 3 assistants. One is for Spring Boot application, which is here on the screen. So it's like some application with H2 embedded database. It has some controllers. So here we have this employee controller. And we want to migrate this Java application to serverless architecture. In order to do that, we have a task inside Jira, which describes that I want to migrate 2 methods, get and post. So I have a description generated by AI. Actually, this was generated by AI based on some bullet points. So it was not written by human like fully, but the main context and what is needed to be done is of course there. And we have the target repository. So this is our target repository, which is completely empty before the workflow is working. So we have taken a look on the assistants which can talk to the Spring Boot application, can work with Jira, and we have this CDK developer, so which will commit the code to AWS DevOps. And you probably noticed that repository is fully empty. There is no CI/CD there at all. So what we can do? We have a workflow. It is a sequential one, which involves these 3 agents. So first of all, we will read ticket from the Jira. Then we will collect all the information needed from the legacy application, and then ask the CDK developer to create a new code. What we do is just put the link to the Jira ticket and relax. So right now, the workflow is starting to work. First of all, it just get the information that we have seen before and put it into the context. And then it decides, okay, so right now I need to collect information about the Java classes which exist in the legacy application, put them into the context as well, because CDK developer will need to understand what to do, not only based on the description, but based on the real code that it has in context. So it will take some time to do all the stuff. And actually, the main difference with workflows and agents comparing to the copilots, it's not only telling you what to do, but it really does the work for you. So here we see some details that we used during the creation of the real code. And we can go to this repository, and we have a pull request. And here we have created files with Lambda functions on Python, which actually do the same logic as was in the legacy application. All we need to do is to merge it. Surprisingly, the CI process started, because the CDK agent was told also to generate the CI and CD pipeline. And right now it can compile, package the Lambda function, and then deploy it to your AWS account that was configured in your CDK agent. So all of that you can actually describe, as I said multiple times before, in natural language. So from one hand side, you can think that it looks like magic and it is only demo, but believe me, it was real. So the guy who was creating it, he did it like in 2 or 3 days, and actually we got to this result. What I would like to also you to take away from this video is a potential. So it's not like this will replace you, but what potential it can give to you. Because if you have a repetitive tasks, then you can have workflows that will simplify it. And I'm coming to the end of my talk, and I promised Roman to leave some time for the questions, and I guess we will have enough time. I want to talk about like current adoption challenges and future trends. About the adoption challenges, I already mentioned some of them, and this is actually resistance because of job security concerns. That is why during my talk, I several times explicitly mentioned that it's not about like taking away job from you. It's about giving back time to you. My personal dream with the help of AI to work not 5 days, but 4. So this is actually what I would like to do in the future. Of course, it's not only about us as engineers, because there are clients who are really right now are resistant to give their intellectual property to AI because it can be sold and so on and so forth. And actually, there is a very high risk of data leakage here. And of course, there is hallucination and high failure rate problem. But you in a probabilistic models like AI, it's like it's nature. So it's okay that you have errors. And as an architect, when I start working as an architect, I always followed the pattern design for failure. Because if you really take a closer look on our normal life, something is always going wrong. So there is no way, at least this is my experience. Probably I'm not that really happy person, but in my life, most of the scenes went not the way I planned. So not completely wrong, but not the way I planned. And that is why I had to adopt, I had to change, and so on and so forth. And it can be considered as a small failures, and it's okay. So to have failures, it's okay. An ability to recover from it is basically the key. And that is why AI agents and workflows, they introduce this capability of regression and of self-reflection. And about the trends. So Gartner says that 80% of the code will be generated by AI in 2025. I don't think it is really will be real, but some basement and background for this is already created. Of course, the second trend will be personalization of user experience, because if you can actually boost the feature development, then you can concentrate more on the personalized usage, and because you can analyze more data and you can understand what is better to how it is better to present the feature to this or that client. And the biggest impact will be on testing, because if you create lots of the changes, you need somehow to test them, and testing process will be the key. So this will be the focus of the next following years, and I guess that new strategies will appear in this area. So thank you for attention. You have my contacts here in LinkedIn, Telegram, and EPAM. You can contact me and ask any questions if we will not cover them right now with Roma. Roma, any questions from the audience?
Yes. Yes, they are. Well, thank you very much for this talk. So, well, it's really amazing for me to see a real demo of how AI can be useful. Because yeah, most of the things we have, like everywhere, they're like, yeah, AI can help you, blah blah blah. But these are real use cases. So this is really amazing to see them. Sorry. So to start with, as you mentioned in the last part, test coverage, uh, we have a question from Igor in our YouTube chat about test cases. I can show, I can show the messages from YouTube on the screen, so I will use it. So, but the quality of test cases generated by AI, I assume in this case, is not good enough. It can provide good coverage, but quality of tests are low. And then there is example how it can be achieved. So, how can we fight with that?
Yeah, this is a really good one, and I like this question. And how I actually explain it to my team and why we are doing this. And I mentioned this during my talk. So the level of quality of the test will be lower generated by AI comparing to the human. But if you do not have any tests, it's much worse situation that you have bad tests. Because if you have a legacy application which you don't know how it's working, you cannot create the good tests. But you can create some tests and understand the impact of your change, how much you touched, basically. And that is why it gives you more confidence in refactoring process. And I see no problem that the quality of the test is not good enough. You just need to understand that level of quality. So what you have covered with this test. And if you want more, you can do two things. You can either improve your agents and actually push AI to do the better job, or you can create some tests on your own based on what was already created. And it should boost your work. Roma, you on mute?
Yeah, sorry, I mute myself because not to disturb your answer with my cough. So yeah,
It's
okay.
okay.
So thank you for the answer. Proceeding with other questions. Yeah, we have a lot, and I do see that people are really interesting in this topic. So it's about waves, which you mentioned. So do you think someone already has wave two implemented or close to have
I do. At least in
it? Okay.
because I have seen it with my own eyes. This CodeMe team that I mentioned. So we started last year as a R&D team, and the first thing that I told to the team, you will not work the old way. So there is no need to work in the old way. If we are not eating our own dog food, there is no like sense to do that stuff. And that is why we are using agents like everywhere. So we are uh, the the true story is that and my team forgive me. So you probably hear, but my team forgive me. Not everybody is really fond of AI. So I noticed that about only 30% of the people who are in the team, they can really use those agents by themselves. So all of them can create them, but only 30% can use them effectively and say, okay, I become more productive because I use agents and because I'm fond of it. Sometimes people are saying, okay, it's not good enough and I don't know how to improve it. And that is why I will not use it. And it's also okay. So that is why I could say that in CodeMe team, we have already implemented the Wave 2. And I do really hope that we are really close to implement at least some portion of the Wave number 3. Because what I wanted us to cover with the help of workflows is generation of the unit tests, fixing sonar issues, like real classical technical debt. When I think about the sonar issue, I do really hate to fix what machine told me to fix. If it told me, fix it. Why you are just telling me to fix it? If you know it, how to fix it. And that is why I can help here.
Yep, yep, makes a lot of sense for me. One more question. Is there is a chance that this approach will reduce the need for interns and junior developers, and that the requirements for entry-level positions will become significantly higher?
Oh, this is my favorite one as well. Um, to be a junior, for me, it's like mm, again, guys. Maybe I will tell that it's not a harassment at all. That I will tell right now. So to be a junior is a happiness. I like was really fond to be a junior. So when I was a junior engineer, that was the happiest moment in my life. When I was a junior solution architect, it was the happiest moment in my life because all the world was open to me. Everything was exciting. I was given the tasks that I thought that I would not manage to do, but they were all related to creativity because I was junior engineer 20 years ago. And the first task that I get was, okay, Zhenya, find the barcode on the image. What I know about the barcode on the images, I saw them only as a like on some products, but how to find them, I didn't know. I just start coding and got the results, and I was successful. So that is why, in a classical way, how we think about juniors, that they are our like helping hands. Of course, it will change the situation, but I don't look on interns and juniors in this way. I look at them as a future, as an open-minded person who does not have really constraints that we as a seniors have. So that is why it's just a change of paradigm.
You know, I heard a joke a couple days ago. Like in my childhood, I hate when somebody told me what exactly should I do. Now in my adulthood, I want somebody to tell me exactly what I should do with a step-by-step plan.
Yeah, but this can be replaced with AI, Rob.
Okay. Yeah, we will discuss it on the day three when we have panel discussion.
Sure, sure.
Okay, so question about more like a vision in the future from Igor. With AI tools as an integral part of the software development lifecycle, will there be a shift in how software engineering teams are structured? And if so, what might that look like?
Yeah, it will, and I hope it will. Uh, the structure. Uh, ah, so as you probably remember, I showed like different roles that appeared in IT recently, and for me, there is only one real role in IT. It's engineer. All the rest are specialization. And what I would hope how the teams will change, that we go back to engineers, not to specializations. So when you, and actually, this is what agile about is. So this agile is about the team which consists of experienced person who are replaceable and can do like almost any task. So this is what agile about. And that is why with the help of I hope that we will cover our gaps in certain technologies because as a human, I cannot know every library, every technology that is used on the project. I can understand what it do, I can understand its constraints, but I cannot operate it really well because it takes a lot of time.
Okay. One more question from Andrei. You mentioned you had success with specialized agents, but not with generic ones. Have you experimented with hierarchical organization, high-level agents orchestrating specialized ones? And related question: what was your experience with agents interacting with each other in general?
Uh, this is basically what we call AI workflows. So this is what we call wave number three. And the experience right now that the sequential workflows, they work well. So recently, one of our colleagues in CodeMe team fulfilled at least a part of my dream, and I'm really grateful to her. So what she did, she created a workflow that is triggered when the release is done, and you need to create a newsletter about the new release with what is inside and send it automatically to the users. So before that, uh, some persons, they go to Jira, they understand, okay, what we have done here, what we have fixed, and you get some newsletter. Is it good? Probably yes. Is it complete? Probably yes. You will never know until you will check it. With AI, it's the same, but it's free. I mean free from human time perspective, not from the cost perspective. And even if it contains mistakes, it's okay. Because in the previous way of creating a newsletters, the mistakes can be there as well. And that is why in CodeMe we always write who is reading those emails and who is attentive. There is a disclaimer behind. It is fully generated by AI.
Okay, so you mentioned cost, and next question is related to that. So you also mentioned different models which you use, and that Sonnet release was a game changer. So the question: for your agents, are you using a highest quality models available in the market right now for everything, or have you run into situation where 4.0 Sonnet is too expensive for some tasks, but 4.0 Mini, Haiku, Flash cost acceptable amount and solve the tasks adequately enough?
Yeah, we experimenting with local LLMs as well, not only with leaders at this moment. And basically, in future, I think that specifically trained models will be more effective because it's no, it's like what happened to all of us. So as an engineer, I cannot like as a Java engineer, I cannot compete in effectiveness with JavaScript engineer because this is not my focus. Of course, I can do this stuff in JavaScript, but I will do it like on an average level. And the same can be true for the models as well. So if they will be trained specifically for some tasks, then they will be more effective, in my eyes.
Okay. And I think the last question, the most tricky one, and the question to you as an architect. So it's nice that you're talking that AI can substitute some development role. But is it possible to use AI agents for architectural tasks rather than
I
for
hope.
development ones?
I hope. As I said, um, I do not want. I do not want to work more. I want to work less, and that is why how we use AI in architecture. It can describe the diagrams that you have created with the text, like no brainer at all. It even can create the diagrams for you, no brainer at all. It can also fulfill the scenarios for non-functional requirements. I think that this question still contains that message that AI will replace somebody. It's not about the replacement. It's about like giving a chance for humans to do the job they are supposed to be doing. So that is why if I have a routine and I have, as an architect, a lot of routines to support documentation, to do the cross-check of the requirements, and a lot of other stuff that I would really gladly delegate to AI. But AI will never, probably never, or even in some future, will replace an architect who is creating something new. So the creativity will still be the focus of the human. The execution can be delegated to AI.
Yeah, so this relates me to another joke in internet that AI can perfectly do pictures, etc. But I want, so we have time to do dishes and cleaning, but I want AI to do dishes and cleaning, so I would have time for pictures and songwriting. So
That is actually the case, because it's not about creating the images, of course.
yeah, but I mean, this is what what you was talking, that yeah, we need time for creativity to really develop systems and their stuff. So we want AI to do boring stuff for us, so we can focus on really interesting. So I think that's we have more questions, but we don't have time. So again, I want to thank you very much for this talk. Really inspirational one, and really interesting that it's something really close to us. So thank you very much. Thanks for being on Java On, and thanks for delivering this talk.
Thank you, colleagues, and have a nice conference. Enjoy it. Bye.
Thank you. Bye.